Okay, so in this warm-up, you should have done it, and now you should be checking your answers. If you haven't done it yet, pause the video, make sure you work through it, and then check your answers. But it says the volume of a cone, so we're dealing with the cone and the volume. So volume of a cone is 1/3 area of the base times the height, and since it's a cone, your area of the base should be pi r squared because it is a circle. So the volume is 56.55. And the 1/3 obviously doesn't change. It's looking for the radius. And then the height is 96. So if you multiplied 1/3 and 96 together, you get 32. So you get 56.55 equals 32 pi r squared. So I'm going to divide both sides by 32 pi. And then when you square root both sides, since you're just left with the r squared, you end up getting 0.75. And this is feet, and that's your radius. Okay. Over here for number 2, it says the diameter of the circle is 3.2 miles. So that means you can chop that in half, and your radius is 1.6. You want to find the volume of the cylinder. So volume of the cylinder is area of the base times the height. Same thing, your base here is a circle, so it's pi r squared times the height. So your volume is pi times 1.6 squared. And then when you get to the height, you don't know that, but you have this 24-degree angle. So I'm going to do tangent of 24 degrees equals opposite over adjacent, and when you solve, your actual height is 3.59. So that's what's going to go in your formula here. And then your volume ends up being 28.87. In this case, it's miles cubed. Okay, so that's a quick review from yesterday. So what we're going to do today is we're going to take the volume formulas that we used yesterday, and now we're just going to use them to compare figures. And then we're going to use the volume formulas and do some converting. So we're going to go back to almost like when we were doing the similarity unit and set up proportions. So for number 1, it says for the dimensions, find the dimensions of a cylinder that has the same volume, so that's important, the same volume as a square prism with a base area of 9 square meters. The cylinders in the square prism should both have heights of 5 meters. So if you think about it, this is your prism. Your volume is area of the base times the height. Same thing here. In this case, your volume is going to end up being pi r squared times the height because it's a circle. This is a square. They tell you that the area of the base is 9. So we want these to have the same volume. So over here, we don't know what this radius is. So I'm going to start with my prism, because if you look, the only thing you have enough information for to actually find the volume or any other dimension is the prism, because you don't have the volume, but it tells you the area of the base is 9 and that the height is 5. So you can say, okay, here the volume is 45 meters cubed. If you had tried to do the cylinder first, you would have run into having too many variables because you don't know R and you don't know V, so you only would have been able to substitute in your H. So now that we were able to do the prism, the same volume is going to help us out here because it says these have the same volume. So now I can go ahead and say, okay, well, if they have the same volume, that means that the volume is 45, and then I have pi r squared, and the height is 5. So now my only unknown is the radius, and the question's saying find the dimensions of the cylinder. Well, we know the height is 5. The other dimension we need to find is r. So we're going to divide by 5 pi here. Maybe. I don't know where that went. Okay. So these all cancel. You have 45 over 5 pi. You don't need to simplify that. Equals r squared. Square root both sides. And you end up getting a radius of 1.69 meters. So in order for these two shapes, the cylinder and the prism, to have the exact same volume, the radius of the cylinder has to be 1.69 meters. So that's what the question is asking, essentially. So now we're going to do the same thing down here for example number 4. Example number 4 says, find the dimensions for a cone that has the same volume and the same height as the pyramid. Both the cone and pyramid have a height of 2 meters as shown, and then it gives you the volume of the pyramid is 3 cubic meters. So here you have 1/3 area of the base times the height. Same thing here. And you can say, okay, well, area of the base, this is going to end up being pi r squared because it's a circle. Okay, so we need to find the dimensions of the cone, which tells me that I should start working with the pyramid first if they're actually wanting me to end up with the dimensions of the cone. So for the volume, it says the volume of the pyramid is 3 cubic meters. The 1/3 isn't going to change. It says that the height is 2 meters, but it actually doesn't say anything about the base. So that's what we're going to be solving for. So you get 3 equals 2/3 b, area of the base, because the 1/3 times 2 is 2/3. If you multiply both sides by 3/2 or divide by 2/3, whatever works for you, you end up getting 9/2 or 4.5 for the area of the base. Well, if you think about it, this base kind of looks like a square, but it doesn't say that it's a square, so we can't be 100% sure. And the question's asking to find the dimensions of the cone. Well, they have the same volume, so what that tells me is that the volume here is 3, so then this volume for the cone has to be 3. The 1/3 obviously isn't going to change. Now, our area of the base is pi r squared. We don't know the radius, and the height is 2. So, essentially, you can go through, and now you can solve for your r. Essentially 9/2 area of the base. You can just do substitution. You can say, okay, it would work out mathematically, but you get 9/2 equals pi r squared, because your b and your pi r squared are the exact same thing. So if b is equal to 9/2, then pi r squared has to be equal to 9/2 if these are going to end up having the same volume. So I am going to divide by pi. You end up getting like 1.43 something. You can obviously throw that in your calculator and then square root that answer, so you don't need to round, but you end up getting 1.20, and that's meters for your radius. So in order for these two shapes to have the exact same volume, and they obviously have the same heights from the picture, if that's going to happen, the 1.2 needs to be your radius. Okay, so on the next page, sorry, I don't know where we're going here. All right, so here on the back of your notes, you have a new art museum that's being built in the shape of a square pyramid. So again, you always want to know what shape you're working with. So it's a square pyramid. The height's going to be 50 meters, and it tells you the actual space needed inside, so that's your volume. And it wants to know what the side lengths of the base of the pyramid should be. So your volume of a pyramid is 1/3 area of the base times the height. It tells us the volume is 86,400. It doesn't tell us the area of the base. It does tell us it's a square, so let's keep that in mind, and the height is 50. Okay, so if you go through and actually solve for the area of the base, you end up getting 5,184 as your area of the base. So all I did was multiply 1/3 by 50 and then divide 86,400 by that answer, and it ends up being pretty. So make sure you can do that on your calculator. But it's asking for what the side lengths should be. Well, if you think about it, what do we know about a square? We know a square has all of the same sides. So the area of a square is essentially length times width, but it's the same thing, so side squared, right? So we know that it should be 5,184 for our area. Well, that needs to equal side squared, so you just take the square root of it. And that's because it's a square. We're taking the square root because we need two sides that are the same, and when you do that, you get 72. So one side is 72 meters. All right, So now we're going to move on to using those volume formulas, and we're going to do some converting. It's not hard. You just need to make sure you set up nice proportions and keep it clean and consistent, and you'll easily get the correct answer. So this says a cylindrical swimming pool, so it's a cylinder, has a circumference of 125 feet, and the water in the pool is 5 feet deep. They want to know the volume of the pool. Well, volume equals area of the base times the height for a cylinder. And if it's a cylinder, the area of the base is pi r squared. And now you have times the height. So here, they give us the height is 5. But if you look, you aren't given the radius specifically, but you are given circumference is 125 feet. So I'm going to come to the side here and say, okay, well, circumference equals 2 pi r. So I have 125 equals 2 pi r. Divide by 2 pi. Make sure when you put that in your calculator, you throw that 2 pi in parentheses if you do it all at once. And you end up getting a radius, which is 19.89 feet in this case. Now I have enough information to go ahead and figure out what the volume of that pool is. The volume is going to be pi times 19.89 squared times the height, which is 5, because it's 5 feet deep. Okay, so when you throw that in your calculator, if you do so correctly, you should get a volume of 6,214.26 feet cubed. Okay. All right, so now the next question is saying, so this is when we start doing some conversions. It says, how many hours will it take to fill the pool with water? Assume the water flows 5 gallons per minute. Okay, so we know that the pool is 6,214.26 feet cubed. And they're giving you this 1 cubic foot is 7.48052 gallons. So what we need to do is we need to convert this volume to how many gallons the pool holds, because we know the water flow in gallons, and then we can figure out time. So the way you're going to do that is this. You're going to say, okay, I know from this right here that 1 foot cubed, 1 cubic foot, is 7.48052 gallons. Okay, and you're going to set up a proportion. Well, if you did feet over gallons on the left-hand side, then you need to do that exact same thing on the right-hand side. We know that the pool is 6,214.26 feet cubed. We want to know how many gallons that is. So as long as you're consistent with feet over gallons and feet over gallons, now you can cross multiply. Well, when you cross multiply, 1 times x is just x. And then 7.48052 times our 6,214.26 is going to get me 46,485.90 gallons. Okay, because remember, we're solving for how many gallons that is. All right, so that's not the question. The question is just saying how many hours. Well, now we know how many gallons it takes. We have 46,485 gallons of water to take care of, and we can do 5 gallons per minute. So I'm going to take that 46,485.9, and I'm going to divide it by 5, because I want to know how many minutes it's going to take me so that I can eventually get to hours. So when you do that, you end up with 9,297.18, and that's minutes. So that's essentially that's gallons per minute. No, sorry. This, not gallons per minute, I'm sorry. It's going to take 9,297.18 minutes, excuse me, to fill the pool by doing 5 gallons per minute. So still, that's not the answer, because it's asking for hours. So now I say to myself, okay, well, how many minutes are in an hour? There's 60 minutes an hour. So 9,297.18, I'm going to divide that by 60 minutes, and I get 154.953 hours. So that's your final answer. It's going to take 154.953 hours. So just a quick recap on what happened there. The part A, we just went through and we solved for the volume. We had to do this little extra piece here to get the circumference, or to use the circumference to find the radius, so then we could actually find the volume. Hopefully that wasn't too bad for you. Then we took that and we converted that feet cubed. Well, I wanted to know, okay, if I have this many feet cubed, how many gallons am I going to have to get in this pool? So we found that by doing our our proportion and make sure you're consistent there. And then from there, we're told it's 5 gallons per minute. So I divided that by 5 to figure out how many minutes it would take. And then I divided that by 60 to figure out the hours. Okay, so like I said, it just takes a lot of work. It's not super difficult stuff, but you really need to write this out and do each step if you want to really be able to see the pattern of what's going on, and especially if you want us to be able to grade it correctly. Okay, so we're going to practice again. The next one says a conical cup is 15 centimeters long. It has a radius of 4 centimeters, and it wants to know how many liters of water the cup will hold. Okay, and so the very first thing we need to do is figure out the volume, because everything's in centimeters. We need to figure out the volume in centimeters, and then we can convert it to liters. So, conical cup, conical just means cone. So we're looking at the volume being 1/3 area of the base times the height. And your volume is then 1/3. Your area of the base is pi r squared times the height. So it gives us the radius, but it says it's 15 centimeters long. So when you're thinking about this shape, what that really means is this is 4 centimeters. If you drop down the center, it's giving you the 15 as the radius, or as the cup is 15 centimeters long right there. So we're going to do Pythagorean theorem, and then we can actually go through and figure out the height right here. So we can do 4 squared plus h squared equals 15 squared. So when you do that, you get h to be 14.46. And the reason I'm saying that the 15 is here, you guys, is because it didn't say a conical cup has a height of 15. It's saying it's 15 centimeters long. So if it's talking about the height, it's going to be pretty explicit with the height is this. So now that we know the height, we can say, okay, my volume is going to be 1/3 times pi times 4 squared times my height, which I just found to be 14.46. Okay, so when you throw that all in, your volume ends up being 242.28, and that's centimeters cubed. But it's not just asking for the volume, it's asking for how many liters it'll hold. The nice thing is we don't need to do a lot of conversions like we had to do in the last problem. Here we can just say, okay, 1 liter, and these conversions will be given to you, we're not going to expect you to know them, is 1,000 centimeters cubed. So I want to know how many liters then, so x liters are in 242.28 centimeters cubed. And if I look at this just for like peace of mind and like a good check, if 1 liter is 1,000 centimeters cubed, if I did this correctly and I'm dealing with 242.28 centimeters cubed, I better hope that this x is smaller than 1, because if 1 liter takes 1,000 cubic centimeters, then I need this to be smaller than 1, since my cubic centimeters over here are smaller than 1. So when you cross multiply, you end up getting 1,000x equals 242.28. Divide both sides by 1,000 and you get 0.24, and that's your liters. Okay. So take your time with these conversions. Go through that thought process that I've been talking about, which is, what is the question asking for? What do I need to get there? What do I have? Of what I don't have, how do I get there? What do I need to get there? And break it down that way. And then it'll be a little bit easier. Okay? And now you can start your homework.